Hello everyone, this is Muhammad Ikhlaq Wahid from Islamia University of Bahawalpur. In this video, I will be explaining my final year project text to image generation system. First, we install the important libraries that are diffuser. We install diffuser to use stable diffusion model transformer and accelerator for model loading and performance optimization, soft tensor for safe model weight handling, Gradio to build the user interface, dataset for data handling. These libraries allow the user to load the AI model, generate images, and build an interactive web application. There is also optional support for X-formers, which can improve GPU performance, especially on CUDA system. Important libraries. Next, we import all the necessary Python libraries here. OS is used for file and folder management. Torch is used for running the AI model on CPU or GPU. GC helps clean unused memory. Warnings is used to hide unnecessary warning messages. JSON helps store feedback and image history. We also import stable diffusion pipeline for diffuser to load the model, date time to store timestamps, PIL pill which we call pill to handle images, Gradio to create the user interface and sequence matcher to compare next text similarities between the prompts. Device selection and model setup. Now we configure the device and load the AI model. First, the program checks if a GPU CUDA is available. It uses it. Otherwise, it falls back to CPU. Based on the device, we use float 16 precisions on CPU for better speed and float 32 on CPU for stability. Then we load the stable diffusion model called runway ML stable diffusion dash v1 dash 5. The model is moved to the selected device and safety checker is disabled to avoid unnecessary interruption. We also enable attention slicing. We helps reduce memory usage and prevent caches on how we are VRAM system. Helper functions. This section contains helper function to improve performance and stability. The first function, autocast device, automatically optimize computation. On GPU, it enables mixed precision. On CPU, it disables the gradient to save memory. The second function, safe journey, safe journey cleanup, clear unsaved GPU memory and runs grab collection. These helpers make sure the app runs smoothly even on weaker system. Feedback memory. Now we implement the feedback memory system. We store user feedback in a file called feedbackmemory.json. This memory contains original prompts, improved prompts, a score showing how useful the improvement was. The save feedback memory function writes this data to disk so it's not lost when the app restart. Prompt suggestion. The suggested prompt function compare the current prompt with the old prompts using text similarity. If the similar prompts is found with a good feedback score, the system suggests an improved prevision version automatically. This makes the system smarter over the time. Let's see the UI of the application. This code connects everything to the Gradio user interface. The UI allow user to enter prompts, generate preview images, improve images using feedback, generate high resolution outputs, view images history in a gallery. All these features work together to create a complete and interactive AI model. Now let's see the user interface of this project. We have some dummy prompt that we placed here to use for generating images. Let's say I use this prompt, and the steps, this is for deepening, for the weight, or for the clarity of the image, and the increase in the steps will weighten your image, while the guidance scale is your prompt. Like if you increase the guidance scale, it will strictly follow your prompt. The suggested prompt is from 6.5 to 8.5, so we set it to 7.8. Now we are going to generate image. It will take some time, so let's wait for the result. While waiting for the result, we will explain some. Okay, this is the generated output. Now improve image feedback, we will use ask the user for the feedback. Like this is the dummy prompt as a feedback. Let's improve this image by using feedback. And this section where we set the image at 1024, like this will k to 1k. This is the generated image after the feedback. Now we are going to generate image with the generate high resolution. This is the history, which store the image history that we previously generate from the prompt. Actually, the high resolution image will take more time than the above. So we will wait for this, and after seeing the result, we will go towards finishing the video. See the suggested prompt here. The model suggests us the prompt by itself. In this, we also have a download option, we have a share option, and we can also maximize and minimize the screen. Here, we also have the download option, maximize option. See, we can maximize the generated image. So we can minimize it and see this is the history. It wait for the high resolution image. There will be a much difference in the high resolution image and the above generated images. Let's go, let's go. See, this is the high resolution image. This is generated with the generate high resolution image. So this was my project, and now we are going to finish the video. We are going to stop the video here. So I hope you like the video and my model, and thank you so much.